Hello. Welcome to this short presentation on the integration and management of thermo-solar and photovoltaic energy in heat pumps for sanitary hot water. My name is Manuel Rabanal in the heating department at Daikin. Okay, so let's begin the presentation. In the context of low energy demand projects, the relative weight of sanitary hot water production increases. Although heating demand decreases and cooling demand decreases, as well as sanitary hot water which is maintained, then its relative weight, when compared with air conditioning, increases. Hence, the importance of providing service for this consumption in a very efficient manner. For example, through heat pumps, exclusively for the generation of sanitary hot water, and hence the need to complement these heat pumps with other types of renewable energy. And this is the objective of this presentation. I'm going to describe two types of heat pump for the production of sanitary hot water, complemented by different types of renewable energy. The first is a split heat pump for semi-instantaneous sanitary hot water production with an exterior unit, 2 kilowatts. This will always perform or operate as an evaporator, condensing on a heating coil. Through a heating coil, it will condensate, generating the cooling cycle. Energy extracted from exterior air through the unit, which is obviously located on the exterior. It will heat that tank, deposit or heat accumulator. Well, it will be heated by a thermal battery of 300 or 500 litres. And another heating coil will extract that energy. This slide, well, on the left, as you can see, they're polypropylene tanks offering high efficiency with very high degrees of insulation, and which perform as a battery, as energy collectors or accumulators. So we can also access the energy for a thermo-solar system, a drain-back system or pressurized system that has to be connected so that we can channel that accumulated volume, 300, 400, 500 litres, which can be extracted for the generation of sanitary hot water. How can it be extracted? Well, it's extracted via another heating coil made of stainless steel with a high exchange surface. This is corrugated stainless steel with very high thermal transfer values. And as I said before, this is a semi-instantaneous sanitary hot water production system. As you can see in the image, sanitary hot water is not accumulated. What we accumulate is energy. The SHW is produced as it passes, similar to a boiler. Whenever operated, when you open a tap, shower, or the mains water will pass through that long heating coil with a large exchange surface area, and it will heat as it passes through, heating instantaneously. Therefore, we are not accumulating sanitary hot water. In addition to this, these type of polypropylene tanks or deposits are not metallic tanks. Therefore, anti-corrosion treatment is not necessary because there's no corrosion risk. Similarly, we're accumulating energy in this case. Therefore, we do not accumulate sanitary hot water. Hence, there's no need for maintenance. I mentioned before the need to produce sanitary hot water in an efficient manner, and one way of doing this is to complement the aerothermal heat pump with other types of renewable energy. For example, thermo-solar energy, or even solar photovoltaic energy. But these type of renewable energies can not only be integrated hydraulically or electrically. It's important to manage these resources sustainably and responsibly. And how can this be done? Using smart software and also smart grid protocols. Using the device's control board, depending on the external signal that's sent, you can get the heat pump to adopt different operating criteria. For example, if we are capturing solar energy, thermosolar energy, then we can increase accumulation temperature or not. Or we can even prioritize the operation of an external thermosolar generator, for example, or even a heat recovery process through an additional heat coil, through an additional heat exchanger, which will recover energy from, let's say, a fireplace, chimney, or a wood stove. So it's a thermal accumulator which will integrate different types of renewable energy, prioritizing one type or another depending on the maximization of performance in each case. In addition to these types of semi-instantaneous heat pumps, there are other types of compact heat pumps that can be used to produce sanitary hot water, between 200 and 260 litres, as you can see in the left-hand image. And in the diagram, the section corresponding to the heat pump on the right, well, it's a 260 litre tank or deposit with a 134 compressor, 1.8 kilowatts on the upper part, which will also condense on the deposit. So it's a high efficiency tank which is accustomed to working at higher temperatures and which will condensate on the water, the sanitary hot water collector. And in line with the philosophy underpinning these approaches, it can be integrated with other types of renewable energy. Which types of renewable energy? Well, the usual ones. Thermosolar energy, as you can see on the left. What else can we use? How can we use the sun, apart from thermosolar energy and hydrothermal energy? Well, photovoltaic energy, of course. Photovoltaic energy integrated through a smart grid protocol in the operation of the compressor. And just as with the heat pump that we saw before for the semi-instantaneous production of sanitary hot water, we can also integrate a wood stove in that additional heating coil. The physical integration of renewable energies makes real sense, provided that it's possible to manage this integration in a smart manner. This smart management approach is very similar to the one used in the previous example. In the image, you can see that there are two contacts. These two contact points are connected to the software, to the smart software in this case, which will prioritize the use of one energy or the other. For example, in this case, I've put thermosolar energy, but it could be, for example, a heat recovery process. Or we can prioritize photovoltaic solar energy. And as in the previous case, we can inform the heat pump what we want it to do. If we have, for example, surplus photovoltaic energy, what do we want to do with that energy? Well, we may want to transform the electricity obtained from solar radiation into thermal energy. How can we do this? We can increase the tank set point value and get close to that future sanitary hot water level. Let's say sanitary hot water in the morning, we can cater for sanitary hot water services and we can achieve the peak solar energy uptake level, even when we're not consuming sanitary hot water. So what can we tell the smart software to do? Well, we can prioritize the heat pump and tell it to convert the surplus solar energy into thermosolar energy by increasing the set point value. So for the next service, that energy will have been accumulated. Okay, well, I hope that you found that presentation interesting. I'll leave you with my contact details. And I and also my colleagues in Daikin would be delighted to attend you whenever necessary. Thank you very much.